So finally, moving on to question 10, the last question on this paper. We've got a question on 3D vectors again. So we're told the two planes, pi1 and pi2, have these equations that are given here. And for part A, we have to find the acute angle between the planes pi1 and pi2. So how do we go about doing this? Well, you've got to realise or recognise that this is the scalar product here that we have to use to find the angle, right? And it's an acute angle. So what we know is that this is going to be cos theta. So the scalar product, remember, we dot the two vectors given. So these are our normal vectors here. This r dot here, this is r dot n. So this is our normal vector, and this is our other normal vector. So we're dotting these two vectors. So that's I plus 2j plus k dotted with this vector here. So 2i plus 3j minus 2k. And then we divide this by the product of the magnitude of the vectors. So that's going to be 1 squared plus 2 squared plus 1 squared. And we take the square root of all of that. So square root of 1 plus 4 plus 1. So we square that, square that, square that, we get this. And we're going to times this by the square root here of the magnitude of this. So that's going to be 2 squared plus 3 squared plus minus 2 squared. So that's 4 plus 9 plus 4 again. So if we simplify this, what are we going to get? So we get that cos theta is equal, so this is 1 times 2, so that's 2. 2 times 3 is 6, so that's 8. And then 1 times minus 2 is minus 2, so 8 minus 2 is 6. So the numerator is going to be 6. And then the denominator is going to be square root of 6. Square root of 6, yep, times square root of 17. And then obviously we need to do inverse cos on this, and if we keep it in degrees, we're going to get that theta. Theta is 53.5 degrees. So that's the acute angle there, 53.5 degrees between the planes pi1 and pi2. So that's part A done. So that's the first 3 marks. For part B, we are told that the point A lies on the line of intersection of the planes pi1 and pi2 and has a z coordinate 2. And we're told that it passes through the point A and it's parallel to 5i minus j plus 3k. So let's find the equation of this line L, so B. So straight away we're told that z is equal to 2. So what's our vector going to be? Well, first let's write the equations down of these planes. So we're going to have x plus 2y plus z is equal to 1. So that's just this point here, or this vector here. So it's instead of 1i, it's just x, 2j, 2y, z, and then this is your d, so this is my 1. So that's my first equation, and then my second one will be similar here, 2x plus 3y minus 2z. And that's equal to minus 2. Now we need to consider, what do we get when z is 2, right? We're told that it has z coordinate 2. So let's play around with this. So if we put z is 2 in here, well, that's going to give me x plus 2y, x plus 2y plus 2 is equal to 1. So if we take the 2 across, that's going to be equal to minus 1. And then similarly, let's do the same here. So that's going to be minus 2 times 2, so that's going to be minus 4. And then if we add 4 onto minus 2, that's going to give us 2. So this equation will be 2x plus 3y is equal to 2. And now we just need to solve these. We have two simultaneous equations here. Let's just solve them and obtain a value for x and then a value for y. So we can substitute x into here if we make x is equal to minus 1 minus 2y, and then substitute that back in. So x is equal to minus 1 minus 2y. And then we're just going to sub it into this equation. So we're putting it into here. So 2 lots of minus 1 minus 2y plus 3y, and this has to be equal to minus 2. Sorry, just 2. Positive 2 like that. So let's expand this and then simplify and solve. So 2 times minus 1 is minus 2. 2 times minus 2, so that's going to be minus 4y plus 3y is equal to 2. So let's just solve from here now. So minus 4y plus 3y, well, that's minus y. So this is minus y. So we'll just say this is following on. So minus y, and then minus 2 added, so this is minus 2. To balance the equation, we're going to add 2. So that's going to be minus y is equal to 4. So therefore, y must just be equal to negative 4 or minus 4. So that's the y value. Now we need to obtain the next value. But we've done all the hard work, we've got the y value. All we need to do is just sub this back into here now, our x value. So therefore, x will be minus 1 minus 2 lots of minus 4. So we're going to get here that x is equal to 7 once you simplify that correctly. So we're nearly there. We've just got to get the equation now. We've got these, these points here. So therefore, r, so this is the finishing line now for this question, r. So we're going to in vector form is going to be equal to, so it's going to be 7 minus 4 and 2. Yep, that's fine. And we add a lambda on here. So this is just like a multiple of the parallel vector here. So it's parallel to this. So that's 5, if we do it as a column vector, minus 1 and 3. And this vector here, this 7, this column vector here, 7 minus 4, 2, that comes from the fact that we know x is 7, y is minus 4, and the z coordinate is 2. So that's part B done as well. That's what we want to end up with there for part B. So I'm going to pause the video and we'll get on to part C.